Good morning and welcome to Designing for Sustainability on Earth and in Space. If you have questions for the speakers during the session, please enter them into the chat feature. And now we are pleased to welcome our moderator, Danielle Wood, Director of the Space Enabled Research Group at the MIT Media Lab.
Welcome. Hello, my name is Danielle Wood, and I am so pleased to spend this time with you. Thank you for tuning into this session as we discuss the topic of designing for sustainability on Earth and in space. My hope for this session is that by the end of the conversation, you are asking yourself what sustainability means for you and how you play a role in designing for sustainability in whatever role you play in work related to designs for Earth as well as for human activity in space, both now and in the long-term future. I am the director of the Space Enabled Research Group. We are a research organization based within the MIT Media Lab, and the team is made of graduate students as well as people with doctoral degrees, and we come together to work on key projects as part of our mission. Our mission statement is that we seek to advance justice in Earth's complex systems using designs enabled by space. I hope that when you hear that mission statement, it gives you several questions, such as what do we mean by justice? And how do we know if our designs are advancing justice as we work on technology related to space and sustainability on Earth? Today, I'll be joined by several key colleagues from the Space Enabled Research Group, and I look forward to introducing you to them and inviting you to join us with a very candid discussion about how our research projects are part of answering the question, what does it mean to design for sustainability on Earth and in space? One of the key messages we want to share is that the aerospace community, those of us thinking about how humans will work and live and use tools and robots, both on Earth now, but also in space and orbit around the Earth and beyond, we can play a key role in helping to define a new and useful definition of sustainability that considers social, environmental, and economic aspects, because only when all three are done together can we truly have a sustainable community. Today, I'm so pleased to introduce two other co-speakers with me. The first is Dr. Caitlin Turner. Dr. Turner serves as a research scientist within the Space Enabled Research Group at the MIT Media Lab. She's also a fellow of the Research to Policy Engagement Initiative of the MIT Technology and Policy Program. In these roles, she performs research and mentors students and pursues publications, focusing on several topics, including inclusive innovation practices and principles of anti-racism applied to technology design. Prior to coming to MIT, Dr. Turner also served as a postdoctoral fellow at the Harvard Kennedy School of Government. She is an expert in actually the nuclear field, including engineering and science, and she holds several degrees related to this topic, including her doctoral degree from Stanford in geological sciences, her master's in earth environmental sciences from the University of Michigan, and her undergraduate degree from the University of Notre Dame. Also so pleased to welcome today Mr. David Colby Reid, who is a graduate researcher in the Space Enabled Research Group pursuing his doctoral degree. Prior to coming to MIT, David has been a leader and entrepreneur. He co-founded the organization called FUSA with Lishan Huang. It's a service design and strategy consulting practice based in New York City. David's also studied cognitive science at Harvard, as well as earned a master's in public policy and economics from NYU. So pleased to welcome both David and Dr. Turner for this discussion today. Their voices will be key to our dialogue. Our key goal today is to highlight several projects that are both research and practice from the Space Enabled Research Group, showing this idea that sustainability needs to include these three elements of social, economic, and environmental. I'll first give a few examples of some of the work we're doing in Space Enabled, and then ask for some key input coming from Dr. Turner and from Mr. Reid. Of course, in our work, we're asking the question, how do we know if we're making progress towards sustainability? And one of the metrics we often turn to is the United Nations Sustainable Development Goals. I hope that you've heard of these or you can look them up. They're very easy to learn about. Just search for UN SDGs online. The Sustainable Development Goals give a series of high-level aspirations for Earth, looking at how people need to live in safety and have access to basic needs such as food and water, and also more broad societal needs like gender equality. It addresses the individual level as well as the regional level, looking at city sustainability, and even the international level, looking at addressing climate change, biodiversity in the oceans and on land, as well as asking how our global system of production and consumption can be made more sustainable. In many ways, the Sustainable Development Goals illustrate this idea of considering a combination of economic as well as environmental and social relationships. A social example is the gender equality goal. An economic example talks about the need for responsible consumption and production and reducing extreme wealth inequality and addressing extreme poverty. And on the environmental side, of course, there are several about preserving biodiversity and also addressing climate change. So we see this great example from the global development community. And I would like to argue that we can take a similar approach in thinking about how humans will operate and live in space in the future, and take the lessons from space design and bring them back to Earth. One example of the work we do at the Space Enabled Research Lab is our work contributing to the Space Sustainability Rating. This is one concrete project that's being done in collaboration with the World Economic Forum, as well as the ESA, the European Space Agency's Space Debris Office, the University of Texas at Austin with Professor Moriba Jah, and the Bryce Space and Technology Company. And together we're forming a consortium that is designing a space sustainability rating. The Space Sustainability Rating is designed as a voluntary initiative where operators of satellites from any organization, whether it's government or companies, can come together, and they will then be able to follow a set of guidelines and a checklist that asks, what have they done in the design process, the operations process, and the end of life of a satellite mission to help ensure that it's doing everything possible to reduce the likelihood of creating space debris, or also to avoid collisions with other satellites. This means they're sharing data with other organizations related to space situational awareness. It means that they're doing what they can to avoid dropping objects in space along the way of the mission. It means that they're also considering how to share data about where they are throughout the missions and the operations, and if there are changes in the orbit. And they're also coordinating for collision avoidance. And ultimately, at the end of life of the satellite, operators should be looking for the way to spend the least time on orbit as possible at the end, so they can then free up space for others to enjoy and use access to the orbits. So the Space Sustainability Rating is in the design phase now, and we'll soon be going through a process to do testing with some volunteer organizations that are interested in helping us make sure that we're assessing what we're looking for. In the next few years, we'll see this brought forth as an opportunity to have an operational system that can truly be used on a voluntary basis by satellite operators to help measure and give credit and incentive for those who are doing their best to avoid creating space debris. So this is an example of taking the environmental and looking at some of the economic relationships and saying, can we have better economic opportunities in space by also considering the environmental aspects in space? So that's just one example. I want to bring in Dr. Turner to the conversation and look at another aspect as we highlight sustainability on Earth and in space, having social, economic, and environmental features. And in this phase, part of the work in Space Enabled also considers the topic of anti-racism. We'd like to present the concept that racism has caused, of course, many challenges, and it's a series of policies and actions and designs that create systemic challenges for certain racial groups, for example, in the United States. And it actually is a feature of many of our social and technical systems. And so what we're exploring in Space Enabled is how can we consciously design systems within the space system, but also other complex socio-technical systems that serve society? How can we make design choices that actually reduce the negative impacts of these systems on different racial groups? Or how can we ensure that there's benefits across different racial groups, no matter what kind of system we're using, whether it's public transportation, aviation transportation, or electricity and energy systems? Dr. Turner in particular is an expert on the nuclear field, and of course there's many links between nuclear and space. And I want to celebrate that Dr. Turner recently published with several co-authors an article in the Bulletin of Atomic Scientists discussing both the historical features of racism within the community of nuclear scientists and engineers, but also features of the technology itself and the process that's used to pursue it and test it and store waste, for example, that have differentially harmed different racial groups. Dr. Turner, I'd love to invite you to comment now. Please give us about a 5-minute overview of some of the key messages of this piece in the Bulletin of Atomic Scientists, and share with us how you view an analysis of racism as a form of actually lack of sustainability is really important to understand in the nuclear field. Thank you so much.
Thank you, Danielle. So hi, everyone. Again, my name is Caitlin Turner, and I'm a research scientist in the group. And this piece that Danielle has just given an intro to is in the Bulletin of the Atomic Sciences. It's a free article, and it's called A Call to Anti-Racist Action and Accountability in the U.S. Nuclear Community. So I want to just start by saying, essentially, the takeaways of this piece can be, maybe for this audience, discussed if we think about both nuclear and aerospace sectors, which are very similar in developed and sort of grew exponentially at a similar time in the mid-20th century. They both commingle civilian purposes like science, exploration, and energy, as well as defense purposes like security, international relations, and geopolitics. We can see evidence of this today where we have legal frameworks around the use of aerospace and nuclear technologies for civilian purposes. For example, space sustainability, ensuring that everyone can access space, or ensuring that nuclear energy is an accessible set of technologies for those who wish to have it, or as well as considering norms around their use in a defense context. For example, the Non-Proliferation Treaty in the nuclear sector governs how nuclear weapons should and ultimately should not be used. Regarding the questions of anti-racism, inclusion, and sustainability, what's important to consider about these sectors is that they additionally both developed at a time where the prevalent norms were colonialist and racist. By colonialist, what I mean is that it was accepted that Eurocentric, Western, cultural and behavioral norms were a superior set of norms, and that the norms and cultures coming from the global South, from the Eastern hemisphere, and from other places, for example, those of indigenous people worldwide, were inferior. And so these ideas about cultural norms were then entangled with ideas about the value of people from these places as people and as humans with dignity. So by racist, I essentially mean this last point. I mean any set of ideas that suggests a hierarchy of biology, of culture, of behavior, etc. among races. So when we have the nuclear field developing at a time where these norms were accepted worldwide, and in the US, for example, this was a time where we had separate but equal, or Jim Crow in the South. A key takeaway is that these norms were actually embedded into the norms, logics, and techniques of the nuclear field. It wasn't an exception to these norms, rather they just existed concurrently. And so, for example, during the Manhattan Project, we had a very extraordinary united effort in the US where citizens from all backgrounds and all genders, for example, were working together on science and the goal of trying to produce nuclear weapons. And at what would become Oak Ridge National Lab in Tennessee, there was an example of what were called the Calutron Girls. These were women who actually moved to Oak Ridge, the site that would become Oak Ridge, which was also called Y12, and they worked on uranium enrichment. This was highly notable for many ways, right? This was a time where most women were not working outside of the home. And also it was highly notable because, uranium enrichment is something that now you really have to be technically trained in a very specific way to work on it. But at the time, the Manhattan Project was this uniting scientific influence. And so we had women working on uranium enrichment in Tennessee. However, what we also had was that those women lived in racially segregated facilities. So even though the norm of women working outside the home was violated, as well as women working in scientific pursuits who were not necessarily trained for it was violated, we did not violate Jim Crow. We did not violate separate but equal. And we had essentially African-American women living in different parts of the Y12 complex as white women. Another example is thinking about how we decided where to use test sites for nuclear weapons. And this is something that the United States is complicit in, as well as other nuclear weapon states such as France, the UK, China, and Russia, the USSR at the time. In the United States, we often used sites that were part of our colonial properties. So in the US, for example, in the US mainland, one of the first tests that we ever did was adjacent to indigenous land. And this was a test that, again, we had no idea, we had some idea, but no precise idea of how big the explosion would be, what kind of radiation would be produced, and how that radiation would impact people. And yet we just tested on indigenous land. Similarly, many of the nuclear tests that France conducted were in their colonial territories in Africa and French Polynesia. Similarly, the treaty structures, for example, the Non-Proliferation Treaty, which is the main treaty, which governs how nuclear norms are produced, essentially leaves out epistemic space for the consideration of security, not just from the 5 initial countries that I named that have nuclear weapons, but from countries from Africa, from countries from Asia, from countries from Latin America. So essentially, because these norms of racism and colonialism existed at the time, these impacts were invisible at the time. It was not remarkable, for example, that we had segregated living structures at Y12, because everywhere in the United States, in the South, we had Jim Crow. Similarly, it was not remarkable at the time that, at least to people living in mainland France, that the French government tested nuclear weapons in Algeria. It was remarkable in other ways to the people who lived in those areas, and there actually was some protest there. But essentially, when we look back today, we are sort of on the left and right of the political spectrum, pretty disgusted with this, right? The vestiges of these norms from the early 20th century and before that still very much exist today in the nuclear field and in many other fields, right? But what's important and optimistic, I think, is that we're at a time where, as I said, a majority of folks on all sides of the political spectrum assert that they reject these norms of the past, racism and colonialism. We have people in the US who are Republicans and Democrats and everything outside of those 2 norms as well, saying that they reject this and that they don't want to be this moving forward. So if that is indeed the case, what this article does, and what we hope to encourage in other fields moving forward, is to examine the imprints of these past norms on the systems of today. And hopefully then by looking into this with an attitude of accountability, of humility, of considering this as a systemic issue rather than a personal issue, we can hopefully create an anti-racist future in a socio-technical system like nuclear.
Thank you so much, Dr. Turner. And can you please just repeat for everyone the title of this article in case they want to look it up?
Yes, of course. It's called A Call to Anti-Racist Action and Accountability in the U.S. Nuclear System. And it's published with the Bulletin of the Atomic Scientist. It's a free article. There's no paywall.
So thank you, Dr. Turner. And I just want to reflect with you. What you've done here is highlight an historical analysis first saying that, as you noted, it was unremarkable. It was quite normal at the time that these behaviors, which are racially discriminative and creating, whether it's in sort of by racial groups in the US or by national groups who are treated with colonial postures, that people accepted these to be normal at the time. But then you also highlight that, of course, we can look back and say, well, we disagree with that kind of policy today, but yet there are important things to ask about today, right? So the United States still has several regions that we treat as territories where we would say in many ways there are organizations and locations that do not have the full benefit of participating in the full political system within the United States. And we can ask, how does the US currently treat people who live in territorial locations in the Pacific and the Caribbean? I think we have not finished with some of the practices that you mentioned. And we could ask the question, of course, there's mixed heritage, right? Both in the nuclear field and the space field. On one hand, we can celebrate, but wow, women of many different backgrounds were involved with innovation and had the chance to play a key role intellectually in the development of key technologies. This is also true, of course, in space, where thankfully recently we have a lot more publicity about this story with movies like Hidden Figures. And there's a great book called We Could Not Fail, which highlights the story of several of the men who were some of the first Black engineers working in southern states in the US, who were part of basically the federal government purposely integrating science and technology organizations within space by having federal labs that hired Black people in states like Florida and Alabama. So there's this mixed story that there were indeed progress being made in terms of treatment, but we also can ask, have we inherently inherited some aspects of discrimination or even just discriminatory harm to different groups, both in the nuclear and the space field? And where do you see opportunities, especially in the education process and the career development process for both these fields, nuclear and space, to try to undo past historical patterns?
Thanks for that question, Danielle. That's a really great reflection. So I think that essentially we are quite lucky right now because we have a lot of scholars who have written for quite a long time about things like intersectionality, anti-racism, about equity, about intersectional feminism, post-colonialism, and things like that. And what all of those frameworks are is essentially humanizing frameworks. Whereas a framework of colonialism, of racism says, actually, we're going to sort of categorize this biology or this behavior or this culture as less than human, and therefore we're going to justify, excluding or treating people differently because of that. These other frameworks, what they do is they say everyone is human, everyone is different, but everyone is human, and that's a good thing. And so if we can essentially look to these frameworks as sort of stars in the sky of ways to point to and be, how can we include principles of these frameworks in education, in design, in pedagogy, that's a really great place to. So also, I think these issues, another thing that's great about them is that they're not exactly unique to STEM. They're not exactly unique to the nuclear field. They're not unique to aerospace, but they're really these sort of unifying ideas about, anti-racism, which is as scholar Dr. Abram Kendi posits, it's a framework that says races are equal. So quite simply, races are equal. So we don't have to sort of pathologize the way someone's hair looks or the way different languages develop across the world. And so if we have this unifying assumption, we can essentially, and if we really embrace that mindset, I think we'll start to see a lot of opportunity for an actual change in design systems moving forward.
And just to add one more angle, which is still an ongoing current day issue, you've taught this in the class where you visited, where I teach a class focusing on how we address justice within space-enabled and other technology designs. And you've come and lectured on the topic of nuclear waste as an ongoing topic, which is not yet resolved and does indeed cause harm to certain racial groups, in this case, often Native groups. Can you give us kind of a highlight of some of the key ongoing debates about nuclear waste storage that does still impact people from different racial groups differently?
Absolutely. So nuclear waste is interesting, right? Because when we think about the waste, so every energy system produces waste. They all do, right? The waste that we care about a lot right now at a very mainstream level is CO2. And it's good that we care about CO2 because it's causing havoc in the climate, right? Fossil fuels and greenhouse gases are wreaking havoc upon our climate. Nuclear energy doesn't produce far near the amount of CO2. It produces several orders of magnitude less. But what it does produce is radioactive waste, which is long-lived. And by long-lived, I mean anywhere from tens of years to millions and billions of years. And what's interesting too is that this waste doesn't actually naturally occur. Many of the elements that are present in nuclear waste and the isotopes that are present in nuclear waste are actually only produced by a byproduct of nuclear reactors. So some of the issues that govern this is that you need a place to dispose of nuclear waste that is quite stable, right? And by stable, what I mean is temporally. So thinking about long ways into the future, thinking about thousands of years into the future, millions of years into the future, you want a place where you can essentially put the waste, seal it up, and not have to worry about it. But essentially the same way we have land disputes in other ways, even thinking about less technical things like gentrification, for example, which is not like a socio-technical feature like nuclear, but it's just a phenomenon that occurs with housing and business. We have a very similar sort of valuation of land for nuclear waste happening in the United States, in Canada, and many other countries, right? And what we see is that we're targeting oftentimes, and by we, I mean the governments or the agencies that are tasked with dealing with nuclear waste, are targeting oftentimes indigenous communities with sometimes financial incentives to accept nuclear waste. Sometimes as in the case of Yucca Mountain in the United States, we had situations where really actually consent was not ever given by the state of Nevada or by like the people in the state of Nevada to site a nuclear waste facility there. And that's a really interesting problem because the state of Nevada, of course, doesn't have nuclear reactors. So it's quite an interesting and morally problematic thing to essentially approach communities that do not receive commensurate benefit from nuclear energy or from these sort of systems and say, we'll pay you to take the waste, and also we're not really asking, but you know, can you do this? So I think when we think about nuclear waste and other types of waste, there's this question of bringing it back to sustainability, of basically wanting to put the waste away and then not think about it again. And really, we can't do that, right? We've essentially tried to not think about climate change for a long time, collectively as a society. I'm not talking about individuals. And what are we seeing now? We're seeing, you know, massive shifts in weather and climate that are noticeable, that are impacting people, that are causing billions of dollars in damage, right? And we'll essentially do the same thing for any type of waste, right? Whether it's food waste, agricultural waste, nuclear waste, radioactive waste, waste from mining, things like that. What essentially we're learning is that, and well, we're learning as a society, some have been saying this for a long time, is that we cannot collectively assign land or people as bearers of waste, as sacrificial like land or entities that will absorb the burden of waste. And so I think what's very important, I should say, because when we do that, what actually happens too is that we tend to not design equitably, right? It's morally problematic, and because we've sort of dehumanized or, you know, devalued a certain piece of land, we actually maybe won't caretake for it and steward it the way that we should in order for it to be safe. So essentially, I think when we think about waste as a concept, whether it's nuclear waste, whether it's satellite waste, whether it's any type of waste, we have to shift from this mindset of where can I put this where I will never see it again and never have to think about it again and it won't impact me, to this is something that I have produced or society has produced and I'm either complicit in it or directly made it. And what should I do? What can I do to essentially make sure that this does not cause further harm?
That's such a great summary, and I really appreciate you emphasizing this piece about waste, as I've been reflecting on the reason the aerospace community has to play a key role in redefining sustainability. You've really just highlighted so keenly that we have waste streams like these in a variety of sectors. We see it in the case of nuclear, but we also see it in sort of every geographic location. So there are waste streams into the ocean of solid waste, but also chemicals like mercury. There are waste streams into the atmosphere. Of course, as a collective society, we produce a lot of CO2 and other greenhouse gases through our transportation, our industry, and the sense of moving goods around the world and people. We also have, of course, the waste stream in orbit around the Earth, which is, in this case, human objects that have been launched into space. And I'd say that we have not taken that approach that you mentioned just now, Kate. We have not said to ourselves, as part of our ongoing business activities, economic activities, and social activities, we take responsibility for our waste. Instead, we've pretended that we could instead, well, just ignore it for now. But we're now realizing that in several layers, if we want to continue to expand the number of satellites that can operate in space, we have to take responsibility for waste management. If we want to continue to grow economically and have, you know, industrial activity, we have to consider the impact of climate change. And as you've noted so clearly, it's very common in all these waste streams that those who've traditionally been harmed by racism, colonialism, and other forms of discrimination, they receive the brunt of this harm, whether it's being sited near nuclear waste streams. Also thinking about people who live, the majority of people in the world who live near the equator in regions affected by climate change, they are affected in very direct ways by this waste stream of CO2, both those near the equator and also those near the poles, especially in the northern regions where people are experiencing major impacts in their lifestyle and ability to have, you know, safe access to land, especially in coastlines due to climate change. So we must rethink, and this goes back to the idea that sustainability has social, economic, as well as environmental features, and that we have to look at the relationship between them all. This is a great time to bring in David Colby Reid, because he's going to help us think about some of the economic pieces and so where we start. And actually what's great is we're going to do a thought experiment with David and say, we've just explained a lot of challenges we have on Earth right now, right? We've created these waste streams, they're already there. David in his doctoral research is asking a helpful question, which is, let's think about places we have not yet created these waste streams. So eventually we'll have humans living in communities, And it could be in places like the moon and Mars, perhaps on asteroids, or even on ships that are traveling many distances in space. So since we hope to have communities living together in space in places that we have not yet fully created either economic systems and relationships or created long-term waste streams we need to dispose of, how can we actually start before we are in that phase? How can we start now, thinking about the kinds of economic and social and relational and environmental features that we want in these societies? And David in particular started with the economic piece. So I'd love to bring you in at this time, David, thinking with us about what are some of the key questions you've been asking about the economic and also the legal and political features of societies for the future in space, and how does that help us think about sustainability on Earth? We'll start with the space side and come back to the Earth side when you're ready. But take about 5 minutes to walk us through that. Thank you.
Sure, and thank you for the in the introduction and the platform. Thank you for the organizers for giving us the space to have this conversation. I suppose there are like two main points I'd like to make, at least in this section, and of course we'll hit on others as well. But the first concerns the context in which we'd be operating here, and that concerns the lethality of the space environment. Essentially, well, space is quite hostile to human life, right? Like the unmediated space environment is lethal and quickly. And consequently, any kind of human life and work beyond Earth will be mediated by like many advanced technologies and the systems required for managing them. And these systems are apt to be characterized by hierarchy, routine, and continuous monitoring. So humans living in space will spend the entirety of their time under conditions characterized by these systems. So I think it's fair to ask, like, under constant surveillance and totalizing hierarchy and well-defined circumscribed routines, what are the prospects for democratic social relations in this kind of context? And what are the implications for economic structure and the relationships between different actors in these spaces? So that's one cluster of considerations. Another, and as Daniel was just alluding to here, I mean, is the concerns more the structure of competition and economic relations between actors that we can anticipate in future space economies, right? The main point that I want to make here is that there are sizable first mover advantages that that accrue to anyone who escapes the gravity well of Earth and then can project from there, right? So I think it's fair to ask, like, what does competition policy look like in an era driven, at least in part, by private actors pursuing space exploration and resource mapping and extraction as well? And how do we think about the compounding advantage that might occur in these situations, right? Like, if you're a space actor and you are mining ice from the moon or asteroids that can be used as fuel or radiation shielding and so on, and you have lower launch costs from these places, for example, like, you could imagine different spheres of economic influence, and coupled with the social structure imposed by the characteristics of the technologies required for supporting human life in these environments, we see a scenario, and I think this is reasonably likely, although it can differ on the margins, right? But like, we can have a scenario wherein technology designs form a de facto kind of government and governance structure and a structure of social relations. So those are like some of the main clusters that I think we can talk about here. And yeah, I'd be happy to elaborate on that. But yeah, like that's where I'm seeing interest, that's where I'm interested in pursuing questions for this research, but also spurring conversations among different actors. And I guess if I can amend and add a third point, I want to, as Danielle was saying in her introduction, I mean, prior to matriculating at the Media Lab, I ran a design firm, and a lot of the work that we did was participatory design and participatory problem framing as well. And so I'm interested in how we can both design for democratic social relations in space, but also how we can use democratic processes to design for space. And so we can talk about that too if there's time.
Thanks so much, David, for laying that out. Let's tease apart some of the points you made. First, we can just highlight that as students of space policy, we're aware that there exist these treaties. There's 4 key treaties and the Moon Treaty as well, that many countries who operate in space have signed on to, which gives some sense of what will be the core kind of rules of behavior in space, but many of them are at the principle level, not at the operational level. So of course, we're thankful that through the United Nations Committee on the Peaceful Use of Outer Space, there's been great dialogue, even since the early part of the space era, that said, that countries are agreeing that actually space locations are the province of all humankind, and that there should not be interference by one group to another. And we can draw from the example of Antarctica, for example, and say, well, there's been great examples where countries do operate research bases in Antarctica. It's not led to war. There's been a lot of cooperation. So I think we have these models to learn from. And what's quite interesting, what you mentioned, of course, what we have in the international space law regime is that countries, nation states, are the actors, right? Countries sign treaties, and in theory, countries give permission for private organizations to operate, so that there should be at least one country that's reviewing the plans of private actors. But of course, so many things that are possibly going to happen in the next 10 years, 20 years, or 30 years in space have not been seen before. And so even though there is treaty language that addresses some of the ideas, such as a state can't claim territory on the moon, for example, but the questions, there are a few that remain open, such as what can economic activity be done if you bring material back from the moon to Earth? And so we do, for example, see these debates happening where various countries, including the United States and others, the UAE, Luxembourg, they've created national legislation about how they view. They would say, well, I have the right as a government to allow certain behavior by private sector organizations in my country, and therefore I interpret the treaty, which I have signed, to mean this, and I interpret that, yes, it's possible for a company to bring material back from space to Earth, or to operate commercially with a service based on using resources from the moon, for example. So we do see a very interesting period, right? That literally right now, we're going to see new techniques in the next few years of companies and governments who then are reviewing them with trying new, possibly economic and other operational activities in space. So it's definitely not too early to be asking these questions. And so let's go back to the first point you made, which was that space is dangerous, and that the life support systems that people might use if they're working in a manufacturing setting or a mining setting in space, it's going to be complicated. So can you please speak a bit more about, because if you're a worker, for example, who is engaged in activity overseen by both a company, but also eventually a government, somewhere in a location like the moon, for example, what kind of concerns do you have for the rights of the worker and how they will be able to seek redress for concerns if they, for example, want to negotiate different treatment with their boss who also controls their life support? Can you talk more about that?
Well, yeah, and I find like the cocktail party version of this question is, how do you quit your job when you work in space? Like, say you're 3 years away from Earth by travel or something, what obligations do you have, does your employer have to you, for example? I mean, like, are you required to be fed and, pressurized and supplied with oxygen and like thermal venting and all the rest, or like, like what obligations do we have to one another in these contexts? And so that's at a, you could call that a micro level of like employer-employee, responsibility. There are also like perhaps more abstracted kinds of questions of responsibility, and those might take place between different corporate or private actors or different governments as well. And like the Law of the Sea Treaty, for example, provides for rescue and the obligation to rescue stranded folks, and like that is independent of whatever flag you're flying, right? So I think you could look at these questions at a macro level too, like what responsibilities do we have to one another? And I think the framework that I find most compelling for thinking about like articulating the classes of responsibility that we have. And I'm borrowing from a philosopher, Elizabeth Anderson, whose project is her project concerns democratic equality, and she's an egalitarian and poses the question, okay, well, how do we think about and what is equality for? And her answer is that like, oh, well, we need some kind of equality in order to achieve the kinds of social relations that are supportive of democracy, in paraphrasing poorly, but that's the general idea. And she articulates these three dimensions of social hierarchy that I think can give like top level design guidance for systems of obligations between actors, right? So those dimensions of social hierarchy include hierarchies of authority, standing, and esteem. A hierarchy of authority is one in which like you boss someone around and say like, okay, now do this, then follow step 2, step 3, and so on, right? A hierarchy of standing is one in which the preferences or interests of one party have more weight than the preferences or interests of another party. And the hierarchy of esteem sort of issues, in my opinion, from these antecedent hierarchies, but like we assign moral value and social value to different social groups, and we sometimes demand signs of respect. You think about like Jim Crow South and like black men step off of the sidewalk if a white person is coming, like that's an example of a hierarchy of esteem, right? And so I think that when we're thinking about obligations between employers and employees in a future space context, we should think about like what are the kinds of obligations that try to equalize across these three dimensions of social hierarchy well. And one of the challenges is we were alluding to earlier with the technology and the lethality of the space environment, like hierarchies of authority are basically necessary in a space environment. Like you don't riff on a procedure, when you're operating in a contained, complex environment like that. In a space future driven by more private actors, you will see hierarchies of standing emerge as well. I mean, we can look to contemporary Earth for examples of this. I don't mean to, well, actually, let's use the example of Amazon for a moment. I mean, not least because Jeff Bezos is planning for operations on the moon as well, but like we have a company that pays its warehouse workers reasonably well. I mean, their wage is a living wage and so on. And we see many complaints about work conditions in Amazon warehouses, in part because there's less like autonomy and ability to govern one's own work, right? And that issues from a hierarchy of standing, in which case, the business interests of Amazon outweigh the interests of workers who might want air conditioning at a fulfillment center, for example. That was a case from the news. And so, we can look to different practices on Earth to see some of the consequences of these types of hierarchies at play in space and use them in the design sense as like design prompts for thinking about what are the salient features and how do we begin designing around them. I mean, my vision for not just engineers, but I would say like entrepreneurs and anyone and space agencies, anyone acting in the space environment would be much in the way that like engineers might design for safety or reliability, or an economist designs policy for efficiency, or another policymaker might design for equity, right? Like there are these like top level design considerations. I think a top level design consideration for development in space ought to be the preservation of democratic equality, or the approximation of democratic equality, because I think that's the best insurance that we can devise against really coercive and exploitative kinds of conditions in future space economies. So I believe that's at least partially responsive to your question. I could take another pass if there are features or facets I think we think ought to be elaborated on.
Well, let's continue the discussion. I really appreciate that. That was a great summary you just gave. You gave the example of the experience of workers on Earth in a company that uses technology in such a clever way. Amazon's very efficient at moving packages right around the world country, and it's very helpful. We all depend on it, especially in this time of COVID. But you note that the technology then dictates a certain a lack of autonomy for workers. And I just recall you recently finished your master's thesis. You gave a similar example, highlighting a story like that for astronauts, where a number of astronauts had to finish a space mission quickly, and it's documented that they were feeling stressed about the schedule. They had a number of science research activities to do, and they had to experience a very compressed schedule, saying that, okay, in these hours, you must finish these assignments. And I believe, as you wrote, that they basically, at some point, felt overwhelmed by the schedule and went on something like a strike. Can you talk more about that?
Sure. I mean, so this is the case of Skylab 4, you know, like 70s pre-International Space Station, you know, but this was going to be the longest crewed mission off of Earth in human history. And so we had 3 astronauts who were going up, and there were some interesting changes to some of the schedule and the number of experiments they were expected to run, like in, you know, there were plans for something, but, you know, the preceding Skylab mission didn't accomplish as much as was intended. And so like some of that work ended up getting like pushed over to this final mission. But yeah, I mean, the effect was that the astronauts conducting these experiments found that the schedule that was planned for them was too inflexible and too difficult to navigate. And as they were falling behind on their research activities, you know, mission control began saying like, okay, well, we have to cut into your personal time or your meal time. And, you know, then like the sorts of things that, like, in hindsight and from our point of view look obvious as bad ideas, you know, were being foisted upon them. So like, okay, well, you know, you have to have an hour of exercise each day, because in the previous mission we learned that a half hour wasn't enough. And so in this hour of exercise, like, we're going to schedule this hour of exercise, you know, after your mealtime, for example, because that's the time to do it. And, you know, like, we wouldn't want to do that on Earth, let alone in zero G. And so, you know, these are factors that emerge when we don't have like sufficient voice from the people, the stakeholders most affected by some of these determinations, you know. And so voice in the governing systems and operational routines is important. And to the point you were alluding to, Danielle, I mean, they, you know, I believe it was New Year's Eve or thereabouts, they just turned off or forgot to turn on one of the flyovers, like the communications. And so they went radio silent for a day, and then picked up the next day and negotiated a different, well, and actually this helped inform the way that tasks are allocated and managed on the ISS now. But like that, you know, like, hey, you're given a list of things that need to be done and some prioritization, but there's operational flexibility in performing some of these experiments and in the way that routines are scheduled. And the Skylab team ended up finishing everything with this increased degree of autonomy on time. They did some studies of their own too, and additional things that ended up being useful. And so, you know, I think one of the lessons here is that productivity can, well, obviously we know this in some earthly contexts, right, that productivity is enhanced by having some operational flexibility. But we see in the Skylab case an instance of where this is happening in one of these really constrained environments where there are a bunch of operational concerns that need to be adhered to fairly closely. And so even in that context, that kind of operational flexibility can help with the work output, but also morale and health of the crew. And yeah, I'll stop there on that point.
That's perfect. I think you've been just as we hope to summarize. And so I think just reflecting back with you, the key lesson here is that we see a case where, of course, you do need mission control to have a safe space mission, and you do need cooperation between different ways to navigate the life support technology and just the mission, you know, operations process. But of course, you're mentioning that valuing, in this case, democratic equality as a way to ensure sustainability, both environmentally, economically, and in terms of how the environment's impacted and socially. So all of that, giving voice to people who are affected, whether they're the crew, the employees, people who are living in areas affected by these policies. I think you're arguing for more voice for those who have to experience the result of these policies, both in space communities in the future and also on Earth. And I want to bring Dr. Turner back in, and we can use our remaining time for dialogue with all three of us. So I want to just reflect, a lot of the things we're discussing are reflected in the class I teach. It's called Can Space Enable Designs, Advance Justice and Development. And one thing that we do in the class that we do, the three of us in our research, is we draw from history of examples of injustice as well as resistance toward injustice. And many of us, the three of us, are regularly reading from scholars like Dr. Kendi that Kate referenced, because scholars of issues such as anti-racism have shown us models that we can learn from and historical facts that we can learn from that help us figure out how can we design technology going forward. So I just want to mention Dr. Turner is leading a research portfolio that we broadly call anti-racism and technology design, by which we mean as we better understand the principles and the tools that are needed to actually recover from and overcome the effects of racism on society. For example, the harmful outputs that different racial groups experience today in the United States. And we then ask, how can we use those principles so that whether we're designing a future space community with David's concepts, or we're designing today's waste management systems for nuclear waste, or even designing the future space traffic management system, for example. One of my students has worked on this, Miles Lifson, in his recent thesis. In all these areas, we want to bring in this concept that David mentioned of racial equality and understand concepts such as anti-racism and ask, how can we ensure that the design process is best suited to give value, and as Kate mentioned, humanization of different racial groups, different groups from different colonial experiences, those experiencing climate change, those from different language backgrounds. So many groups have experienced differential harm due to their identity. And so we try to ask, how can we design these complex systems in a way that does not perpetuate that harm? So I think in the minutes we have left, in the next 15 minutes, we want to spend some time, because both of you have reflected on this in your writing, either learning from historical patterns of discrimination and trying to see how to undo that in the future, as well as looking at today's design opportunities. So I'll first turn to Dr. Turner to highlight some of that and come back to you, David, in a moment. But let's talk among the three of us about how we are incorporating anti-racism and other kinds of socially, I guess, respectful approaches to different groups in our design process. And Kate, you can first talk about the research we have in that area and come back to David in a minute.
Thanks, Danielle, and thanks, David. I always love listening to the two of you talk about David's work because it's just so interesting and such a crazy thought experiment, which will, of course, have relevance. So the best kind of thought experiment. But so yeah, I think I will first just mention essentially within anti-racism, and of course you mentioned Dr. Kendi's work, and I recommend those who are interested read his book, Stand from the Beginning and How to Be an Anti-Racist, as well as reading Dr. Kimberly Crenshaw's work on intersectionality. So essentially, really there is, Kendi breaks this down into different types of racist ideas. The first being essentially segregationist racism. So this is the type of racism that says there are biological inferiorities. And this is the sort of racism that we see a lot of, hold on one second.
We're just gonna see if we can fix some ringing we're getting in your mic, Kate. Just try turning it off and turning it back on, it might fix it. I think it's better, go ahead.
Is it still there? Okay, sorry. Yeah, technology is touchy, right? But yeah, so segregationist, oh, okay, it's still here. This is exactly where I've been sitting the whole time, so I'm not sure what to do.
Go ahead and then if you have microphones or a headphone to try out after that, but after you make this initial thought would be great.
Sure, yeah. So I think that segregationist racism is the kind that says that there is a hierarchy of biology within race. We don't really see that sort of ideology as much anymore in mainstream policies, for example. But there's a different kind of racism called assimilationist racism. And I should mention the reason I bring up intersectionality is because this isn't just true across race, but it's true across gender and class and other sociological axes. So assimilationist ideas are the ones that say, that there is a preferred or a superior set of behaviors, of cultures, of preferences, of aspirations, of ways of speaking, ways of existing, and essentially that these are like choices, which is sad actually. So it's because we frame it that way, because we say, it's a choice. For example, it's a choice for me to straighten my hair, right, as a Black woman. And so if I choose to not straighten my hair, and then I experience a, discrimination because my hair is curly, and this mindset would say, well, that's your fault because you weren't conforming to the assimilationist norm. And so there are norms like that about appearance, again, about sexuality, about class, about different markers of how we exist in the world. And those, I think, in technology sometimes help us define what an ideal user of technology might be, or who an ideal consumer might be. And so what happens is that when you have this like humanoid idea that is assimilationist in your head of who the ideal user is of your technology, whether it's something like a cell phone, a facial recognition. I note that, you know, Zoom has this video feature that can touch up your face, but it actually works really well on people with a lighter complexion and less well on people with a darker complexion, right? That is an assimilationist sort of norm. And so if we instead designed with an intersectional anti-racist norm in mind and said, actually, like, we are probably going to have a lot of different kinds of people with different kinds of needs accessing our system of technology, I think then we would start to see a lot better outcomes, both in the design process of technology and of its distribution in society and its interaction with society, but as well as the actual artifacts and systems that we produce in the first place. I'll pause there and try to grab some headphones.
Actually,
thanks so much, Dr. Turner. Please go ahead, Dave. I want to see if you want to respond. Please go ahead.
Oh, well, yeah. So as an example or a different application of the point that Caitlin was just making, you see this in the area of like universal design, right? Like designing for accessibility creates new opportunities as well. I think about the example of disability advocates who prompted, you know, like sidewalks that have curb cuts so that, you know, folks that using wheelchairs can cross streets and get onto sidewalks more easily. Those curb cuts end up having application for, you know, I've lived in Manhattan for, you know, 15 years, and like folks with the like carts, with like your old lady cart with laundry or groceries from the grocery store, it's easier to use, or people like on skateboards can use the ramps as well. And you know, that this becomes another pathway and a different imagination of like how a space can be used when we try to design for more accessibility. And I think that that's an example of what Caitlin was just talking about here, you know, that we see different types of possibilities when we design for and encourage the participation of different, like a broader and more diverse set of users, you know? Yeah, so that was the initial response there.
Thanks so much, David. And I'm growing on what you highlight, because I think one thing that all of us, the three of us, reflect on in our work is that we look deeply at the scholars that have analyzed these points in terms of the experience of different groups. So one piece we can highlight from what Kate just shared is that in our work in Space Enabled, we're asking how tools such as anti-racism or other forms of social equity can be included during the design phase, the distribution phase, and ultimately sort of the outcomes we expect for different social groups, which could be intersectional racial groups, such as Black women, or it could be groups based on class, such as people who work for low incomes close to the poverty line. So we look at these different groups, we can ask the question, what were the assumptions that went into the design phase? So Kate mentioned if you assume that your users are going to have a certain complexion, then you might design in a way that does not serve people of different complexions. It's an input to the design. There also might be just behaviors that are sort of left over from traditional patterns. In recent conversation with people in computer science, they remember there's a tradition of using the phrase master and slave to talk about software. It's just been there for years. It's just a pattern that people say, well, one part of the software is telling the other software what to do, so master and slave must be a good way to describe it. But people who are thoughtful look and say, well, you know, we don't have to use that term. We could take the term master and slave out of that and it's not required. So that's a chance where people can say, let's take old assumptions and old thought patterns and actively remove them from both our process and our products. And then the next piece is to ask, what's the experience of different users, of different groups, different social groups, during the experience in the technology, whether it's an artifact like a cell phone, or whether it's a complex socio-technical system like an airport. You could ask if someone's going through an airport, experiencing buying products, going through security checks, even affording to reach the airport in terms of public transportation. People from different social identities certainly have different experiences in how they engage with security, how they have access to public transportation to reach the airport, and whether they can afford the tickets, for example. Then you can talk about the outcomes, so long-term experience for people. Will certain neighborhoods be disrupted more so by airport construction than others? Will others experience, you know, more opportunities for jobs? And you can start to actually measure for something like an airport or for an artifact like a phone, how does it impact different identity groups differently? And are we happy with that? Are we satisfied with the experience? And these are one of the principles we bring into anti-racism technology design for today's technologies. And then David, I'd love for you to speak that you're now taking the same concept when you talk about the idea for relational equality in future space systems and future human activity in space. You're reflecting on learning from the past and from the present to design that in the future. Please reflect on how you've used historical examples from American history, for example, to inform your thinking of how we should design what we don't yet have, which is the future human activity in space.
Well, sure. I mean, I think, well, I think a couple of things, and we'll see how they fit together here. I think, you know, it's important to learn from I think as a student of history, we see the importance of social identity as an organizing framework for social relations, right? And I think so to lead with the conclusion here, I think we have to be attentive to the types of social identities and social groups that we craft through the technologies that we use. And it's not just a matter of technology itself, but a technology deployed in a context. I mean, both Danielle and Caitlin, you've been talking about ways in which, you know, racist and sexist contexts inflect different practices, right? And I think there's a lot to learn from those types of contexts. And so, you know, some of my early academic training was in psychology, and I tend to think in terms of social and cognitive psychology concepts often. And one of them concerns social identity theory. And basically, it's a meta-theoretic framework that you know links a few different bodies of and lines of research in psychology together. But it's just the idea that that our cognition is bounded and inflected by our identity groups. And identity groups can be multiple, like we have multiple identities that are cued in different contexts. And the things that organize identity are environmental and social factors. You know, like my identity as a man is not super salient to me as I consciously move through the world. But when so in the FUSA project, we were doing work on financial empowerment practices in communities. And there was a community of women in New York, and it was just like a monthly meeting of women talking about financial issues. And in that case, my identity as a man is very salient. And you know, it wasn't appropriate for me to go and participate and observe in that context, you know? So social identities can be cued in salience and also formed by contexts. To go back to the technologies for space example, you know, we should be cognizant of the types of social identities that might be created by the technologies used to mediate the space environment. And so if those technologies have the kinds of like hierarchies of authority that we were discussing earlier, you know, what types of identities might issue from them? And consequently, like how might we remedy some of that, maybe on the back end, you know? And so some of the work that I'm thinking about, and I'd love to work with some more legal scholars on, it's like, how can we use institutions such as property, and can we have property, when we think about property and intangible assets, like a property interest, a claim in a thing, right? Can those be ways of hedging against the effects of encoding socially pernicious identities? So I feel like it's again a first approximation of a response there, but I feel that the big point is that technology can influence the social identities that we hold and the ways in which we relate to one another and process information. And so we should be cognizant of those. Yeah.
Thanks so much, David. We're coming toward the last 5 minutes of our discussion, so I'm going to ask both Kate and David to think about your closing statements. In a few moments, I'll come back to you and ask you to please, you know, take a brief summary of the key thing you want people to take away. So I'll start by doing the same. I definitely want to reflect on what we've heard today and piece it together so you can see that the common thread. I started by talking about how we need a new definition of sustainability that includes economic, social, and environmental aspects, because we aren't able to thrive as a society for everyone unless we address all three of those things simultaneously. And I showed the United Nations Sustainable Development Goals is a great example of a globally drawn consensus that includes key ideas for targets to be achieved by 2030 in all three of those areas. There's certainly areas related to economic improvements, such as in reducing extreme poverty. There's areas related to social benefits, such as increasing education access and gender equality. And there's areas related to the environment, addressing climate change and ensuring biodiversity for both plants, animals, such as coral, and being able to think about that in the ocean, but also on land. So we can draw from this great body of work for the United Nations Sustainable Development Goals, but we also have to ask the question, how did we create such a world that we have today on planet Earth? Meaning, how do we create this situation where, as Dr. Turner mentioned, we really do see patterns in which there are uncontrolled and unmanaged waste streams. We have waste streams in the form of carbon dioxide and other greenhouse gases that really cause and perpetuate climate change. We have solid waste management and the need for better kind of a circular economy of solid goods that are part of our global distribution and consumption. We have the long-term question of managing natural resource management and the question of areas like mining on Earth. And we have the question of how waste streams such as nuclear waste, which have such special requirements, will be managed. And if we move from the sea to the land, to the air, and eventually to orbit around the Earth, humans have already, through our economic activities and our science activities, created an unmanaged waste stream of objects orbiting the Earth. So I mentioned that Space Enabled is working with several organizations in a consortium led by the World Economic Forum to create the Space Sustainability Rating, which is one part of a larger set of efforts to address this question of ensuring that we don't put so much waste in space that we won't be able to operate. And the theme we've all drawn here is that it's required that we think about these aspects to be sustainable, because otherwise we're not going to be able to enjoy as a broader society, the benefits of these great technologies. So those are some of the key things I wanted to highlight. And we mentioned, for example, anti-racist theory as one of the tools, one of many, that we need to draw to better understand how people from different identity groups can better experience the benefits of technology, whether it's today's space technology or the future societies that we may create as humans in space. So we have about 3 minutes left, and I want to invite both Dr. Turner and David to make 1 minute closing comments. Dr. Turner, please go first.
Great. Can you hear me? Okay, great. So yeah, I would say just for my closing comments, I would like to emphasize one thing, which is just that I think it's, there's a lot going on in the world right now. It's been quite a year, and, there's evidence to suggest that the future will continue to have quite a year in each sense, right? But I think we should take heart in one thing, which is that essentially, when we look back at these historical norms, we look back at the racist and colonialist and sexist norms that were really prevalent, and not just prevalent, but accepted and encouraged in the past, we can really take heart and find optimism or pragmatic realism, whatever, in the fact that most people in the world really reject these norms now, right? So was quite something this year to see, for example, how so many people across the left and the right of the political spectrum in the United States responded to the killings of people like Breonna Taylor and George Floyd, right? And so I think that the next step beyond that is looking at it and being like, wow, this is disgusting, it's appalling, it's depraved, it's all of the things, is to say, you know what, why is this issue here? Why are these issues here? They're here because the norms of the past encourage those things. And so if today we want to move forward in society, in all different sectors of society, and create anti-racism, create intersectional anti-racism, create equity in our systems, we should be willing to sort of open that book cover and look into the past and look what shaped these things, and take heart in the fact that we can choose to go forward in a different way. So I want to encourage everyone. It is very daunting, right? I feel daunted myself often when I look at these things, but we have choices to make every single day, and if the majority of those choices are anti-racist choices, they come from a mindset of equity, of all racial groups are equal. I think that would be a really great future to start to begin to build.
Thank you, Dr. Turner. And we have just 1 minute left. David, please give our closing comments. Thank you.
Sure. And, we've been I've spent a lot of my time in this conversation speaking about the further future and further like cislunar and beyond space and so on. To bring it back down to earth for a moment, and also to reference an example that Caitlin opened with citing nuclear waste. For several years I served on my local community board in Manhattan. And this is like, as you imagine Parks and Rec, but in New York City. And some of the challenges, and one of the things we discussed was where to site a sanitation garage. And typically, or historically in New York, sanitation facilities and others like them were sited in Black and brown neighborhoods in the Bronx and Brooklyn. The city passed and implemented a plan called Fair Share about like siting these facilities across the city. And no one wants a big, loud facility in their backyard, but the Fair Share plan forced a lot of negotiations and like broad-based community discussion about like, oh, wow, well, these are the facilities we need. And so where should they be sited, and built a process for doing that. That's an example of voice and having more voice in systems. The Skylab astronauts had voice and enough power to like have their voice be heard. And as we think about designing for sustainability, we have to design for that kind of voice. And that's the point of the democratic equality piece. So the end.
Well said, David. Thank you to both David and Dr. Turner. It was a pleasure. And we want to thank AIAA and the Ascend team for this opportunity to speak today. Good luck to all of you.
Thank you. Take care, everyone.
Thanks, everyone.